Good morning, students. We are going to discuss about CS8603 Distributed System Introduction. Our learning objectives are: we are going to learn about the concepts behind a distributed system and what is the relationship between the parallel system and the distributed system. First, we have to know what is the definition of a distributed system. A distributed system is a collection of independent computers. They are interconnected via the network. Why they are connected with one another means to collaborate a particular task. To complete a particular task, several computers must be connected with one another, and such type of collection is called as a distributed system. So what do you mean by distributed computing means is a computing performed in a distributed system is called as a distributed computing. We have to know what are the characteristics of distributed system. Since the computers are scattered around worldwide, we cannot maintain a common physical clock, and they don't have any shared memory. All the computers are geographically separated from one another, and all are having autonomy in nature, and all the computers may be in different formats. They can go with a different architecture, different instruction format, etc. What are the main differences between the centralized system and the distributed system? So in centralized system, by using a single CPU, we are doing several jobs. Whereas in distributed system, the jobs are distributed among several processes, and all the processes are interconnected with the help of the computer network. In centralized system, we can have the shared memory and the shared variable, whereas in distributed system, we cannot maintain the shared memory and the shared variable, and we cannot have a global state also. In centralized system, we can have a physical clocking facility, whereas in distributed system, we cannot maintain a single clock. So we don't have no global clock. The relationship between the computer system components and the distributed system: each computer has a memory unit and the processing unit. All the computers are connected with one another through a network. So the network may be the WAN network or the LAN network. So how these computers are connected to distributed networks means with the help of a middleware, which is called as a distributed software. By using this distributed software, we are connecting the computers to distributed system, and it derives the distributed system. At the same time, it preserves the heterogeneity of the distributed system. So what is heterogeneity? Different formats, different representation. So each and every computer can have its own representation, its own architecture, its own hardware, its own softwares. Okay, they may be different from one another, but to hide this heterogeneity, we are using the middleware, which is called as a distributed software. So what is computation and what is run? A computation or run in a distributed system is the execution of process to achieve a common goal. It is termed as a computation or run. What are the driving factors behind the distributed system? The main driving forces are inherently distributed computation, resource sharing, access to geographically remote data and resources, enhanced reliability. For these reasons, we go with the distributed system. Inherently distributed computation. So you can perform the computation at geographically remote location. Resource sharing: from anywhere from the world, you can retrieve the database, you can get the special libraries, you can get the file copy, etc. Access to geographically remote data and resources. even my file resides in anywhere in the world, by using the distributed system, by using a distributed software, you can access the remote data as well as you can access the remote resources also. Enhanced reliability. So we can have multiple copies of same resource, that is same file can be replicated to many places. So you can distribute the resources in several locations, so it increases the reliability also. Relation to parallel system. So parallel processing systems, it divides the program into multiple segments and each segment is processed simultaneously. A parallel system is broadly classified into three types: multi-processor system, multi-computer parallel system, and array processor. So what is multi-processor system? From the name itself, we can know that this architecture comprises multiple processors and they can directly access the shared memory and they form a common address space. So this architecture is shown in the figure A. So in these processes, we cannot maintain a common global clock. So here we have two different architectures, uniform memory access and non-uniform memory access. So what is uniform memory access means? All the processes share the physical memory. Okay, that is from the figure A, you can see that all the processes share the physical memory. All the memories can be accessed in a centralized manner. So we maintain the equal access time. That's why it's called as uniform memory access. To access a particular memory word from the memory, all the processes requires equal amount of time to access a particular word from the memory. So that's why it's called as uniform memory access. It provides equal access time. Whereas in non-uniform memory access model, the access time varies. It depends upon the location of the memory word. So here, the shared memory is physically distributed among all the processors called local memories. See the figure B. So each processor comprises its own local memory, and since the memory location varies from one processor to another, the access time also varies. So that's why it's called as non-uniform memory access. So the second type of architecture is multi-computer parallel system. It is also a parallel system. Here also we have multiple processors. But what's the difference between the first one and the second one means, in the second one, the processors cannot have a direct access to the shared memory. So here they may form or they may not form a common address space, and here also we cannot maintain a common global clock. So it is represented in the figure B. The third type is array processor. So they are a class of processors, and the other name of this is known as a vector processor. Why it is called as array processor means it executes one instruction at a time in an array or table of data at the same time. At the same time, the same instruction can be executed on a table of data or on array of data. That's why it's called as array processes. So thank you so much.